The average speed at which an object moves is worked out by looking at how much distance it has covered and how long it took to cover that distance. If we plot this car's motion over a 7-second interval, we can see it moving at two distinct speeds. In the first 3 seconds, the car didn't cover any distance. Its average speed was 0 meters per second. Over the following 4 seconds, it covered 7 meters. When we divide the 7 meters by the 4 seconds, we get the average speed of 1.75 meters per second. If we then take this data and plot it on a speed time graph, we get something that looks like this. Acceleration is a measure of the change of an object's speed over time. Realistically, a car wouldn't instantly transition from standing still to having a speed of 1.75 meters per second. It would work up to that speed over a period of time. Let's say that time period was 4 seconds. If we do the distance time plot, we see that the car covers more distance per second towards the end of the time interval once it is sped up. This is the effect of acceleration. If we do a speed time plot with the accelerating car, we can see that the acceleration is the gradient of the plot. If we let this car accelerate at the same rate for longer, we would see its speed steadily increase. As we've defined acceleration as the rate at which an object changes its speed, it makes sense that the SI acceleration unit works out to be meters per second, or simply meters per second squared. Gravity is a force. When a force acts on a body of mass, it causes the body to accelerate. This is why when our car drives off the cliff, it rapidly increases its downward speed. Gravitational acceleration happens at 9.81 meters per second squared.